Alright, in this video we are going to be looking at linear equations. We'll look at ways of solving them, look at a couple of rules, we'll look at some applied problems. We'll also talk about finding zeros of a function and finding y-intercepts or f of 0. And we'll also finally look at just solving some quick formulas for a particular variable. So first off, in terms of solving equations, you need to know the difference between an equation and an expression. An expression is something that if you're working on a question, you can simplify. Often, actually an equation is two expressions that are made equal to each other. But in an equation, what you're looking for is to solve the thing. So in an equation, you're looking at the end to come up with x is equal to some number. But when you simplify, there's not an equal sign in an expression, and so all you're doing is rewriting something. So say, for example, you have 2x plus 8 plus 7. If I was asked to simplify, I could look at these two and know that they're like terms, so I can add those together, and I've simplified then this expression. In an equation, you would take that a step further and actually, well, not a step further, you would, it's a different thing. Like this one, you just rewrite it, whereas with an equation, I guess you rewrite it in steps, but your main goal is to get x on the side of an equation by itself. Here's some examples of some equations that you could solve, and some of them you may have solved before, some of you may not have. This is a linear equation. You could move the 3 to the other side by using a property and then get rid of the 2. What I'm looking for is x by itself. This one, hopefully you've done lots before. Quadratic equations, same kind of thing. What you're wanting to get is x by itself. The problem with this one is you have 2 x's, and one of those is squared. So with this one, there's a different way that you have to solve that. And basically, if you factor it, and then you can treat each of these as a linear equation and solve. Here's a trig equation, same kind of thing. I want to get x by itself, so I want to get rid of this sign somehow. So there's a rule to do that. Here's a cubic expression. Again, different ways of solving this one. Since it's cubed, there's actually 3 different answers that could have. So there's other ways to do that. And here's a log equation. To solve this one, there's a certain property, but again, what you're looking for is to get x on the side of an equation by itself. And we'll look at logs later in the course. So, a couple of the principles that you should be comfortable with are the addition subtraction or the multiplication division principle, or both of those. Addition subtraction principle says something like this. If you're wanting to get x on the side by itself, and on this side you have a subtract 4, then what you can do is you can add 4 on this side, and that's the additive inverse property, I think it's called, where if you have subtract 4 and add 4, they cancel out or give you 0. And so on this side I have x plus 0, or just x. On this side, if I add 4 to this side, the rule says you have to add 4 to that side. So 5 plus 4 is 9. That's the addition or subtraction principle. Multiplication division principle is similar to that one, but if I have an equation like 2x is equal to 10, you could probably figure out 2 times something is equal to 10. You could figure out what that number is, but you can also use this principle. So if I want to get rid of this 2, since it's being multiplied, I'll do the opposite operation, which would be divide. So I'll divide this side by 2. If I do it on this side, I have to do it on this side. This is the multiplicative inverse property, where if you have 2 divided by 2, that's equal to 1, and 1x is just actually x, and 10 divided by 2 is equal to 5. Often you'll need to work with those principles in conjunction with one another. Why don't you press pause and just try these 2 equations, and then press play and see if you've got them right. Okay, hopefully you press play. On this one, I'd use the addition principle on both sides. I come up with x equals 13. With this one, I want to get x by itself, so I have to get rid of the 2 and the 3. What I want to do is get rid of this 3 first. It wouldn't really matter. You could do the 2 as well, but you'd have to remember to divide everything by 2. It just turns out that if you subtract 3 on both sides, it makes the question just a little bit easier. So this would be 2x is equal to 12, and then I'll divide both sides by 2. I come up with x is equal to 6. Notice that here I didn't write the divided by 2. I just sort of did that in my head. If you're okay with skipping the steps like that, that's fine. Just don't skip too many of them. Here's a couple other questions where you might need to use some other properties. This one here is the distributive property, where you have brackets and a number out front, and I could distribute that amongst those things. Here's a negative sign out front of a bracket. I would have to also distribute that across those. And then collect like terms and do the other stuff. I'll do this one. 2 times x is 2x, 2 times 2 is 4, minus 3x, and minus 1 is equal to 7. And then maybe I'll leave my x terms on this left side, so 2x minus 3x is on this side, and then I'm going to move all my numbers to the other side. So I'm going to subtract 4 on both sides and add 1 on both sides. Yeah, hopefully skipping a few steps there wasn't too troublesome for you. So 2x minus 3x would be a negative x. 7 take away 4 is 3, plus 1 would be 4 again. Now it's negative x equals 4. I don't want a negative x. That's sort of like a negative 1. So I could divide this side by a negative 1 as long as I divide that side by a negative 1. So on the left side, I'll be left with an x, and on the right side, 4 divided by negative 1 is negative 4. Okay. Next one would be a similar question to that one. Get the x's by them on one side and get numbers on the other side. Here's another equation where it's a log thing, but what I'm wanting you just to focus on is that there's rules to go from one step to another step. This particular one you wouldn't have seen in a question like this, but there's a rule that governs this. And the one rule says, a product rule says, if I'm adding logarithms, I can write it with one logarithm, and I multiply that stuff that's inside there. Okay, so I multiply this by that. So I've combined those two things into one log. Then there's another rule that says I can change something from log form to exponential form. So it'd be 2 to the first is equal to x plus 2 times 3x minus 1. That's this rule right there. Now, right now I don't care that you know those rules. You will when we look at logarithms. But my point is that there's rules that govern going from one step to another step. And when you're doing any kind of solving any kind of an equation, make sure that you indicate somewhere what rule you're using in order to go from one step to another step. Even if it's on the side, saying, hey, I use the product rule. Or to go from here to here, I changed from log form to exponential form. So just writing what rule you're using to go from one step to another step, always a good idea. Okay, so let's maybe apply some of these principles to some worded problems. Typically, these are questions that people are challenged with quite a bit, but what you need to keep in mind is practice. If you do lots of these questions, you get to sort of know how the questions go and the steps that you go through to solve them. So you just need to practice them. I'll give you just maybe one question. We've got one, the length of the largest regulation soccer field, love soccer, is 30 yards greater than the width. Okay, so let's draw. Okay, here's a soccer pitch right there. And it says the length, so L, is, that's equals, 30 yards greater than the width. So here's the length, and it says it's 30 yards greater than the width. So if you take the width and add 30, you get the length. Okay, and this is the width. Then they say the perimeter of the thing is 460 yards, and they want to know what the length and the width is. Well, you could probably try and rationalize and put some numbers in there and just start guessing, but I can use some rules or some principles that I've seen before. Specifically, here's one that governs the perimeter of any rectangular shape. So I have the perimeter is equal to 2 lengths plus 2 widths. That's my rule. Now I can plug things in. They say the perimeter is 460, so I'll put that right in there. And that's equal to 2 times whatever the length is. Well, up here, it said the length is 30 plus the width. So I can put that right there, 30 plus the width, plus 2 times the W. Okay, following, this is a linear equation. I can follow the same rules as I did back, oh, not on that one, back on this equation there. So I'm going to multiply the 2 through here. So it'd be 460 equals 2 times 30 would be 60, right? So it'd be 60 plus 2W plus another couple of W's. So here I have an equation where I just have W's. Let's get those together. So 2W plus 2W is 4W. And then on this side, I'm going to have 460. And I want to get rid of this. I want to put it over with that. So I'll subtract 60 here and subtract 60 on this side. I know that when I subtract 60 on this side, they just cancel out. So 460 minus 60 is 400, is equal to 4W. Divide both sides by 4. And I get the width of this soccer field is 100. So if the width is 100, we write that in there. So if the width is 100, then the length, width is 100 again, the length is 30 plus 100, or 130. So if they want to know the length, it's 130, the width is 100. Okay, maybe here's another question what we could solve that way. So it says I have a triangle, x, y, z. Let's draw a triangle. X, y, and z. Angle y, that's this one, is 5 times as large as x. So x we'll just call x. But it says y is 5 times as big as that. So this has to be 5x. Then it says the angle z is 2 degrees less than x. So if I take x and subtract 2, that gives me z. Now, one of the things I know about triangles is that all of the angles of a triangle have to add up to 180. So I've got x, the angle x is x, y is 5 times x, and z is x. Measure of z is 2 degrees less than that of x. So take x and take away 2. Yeah, equals 180. Now I've got another linear equation. Let me drop the brackets. X plus 5x plus x minus 2 equals 180. I'll gather x's here. That looks to be about 7 of them. Is equal to, if I add 2 on both sides, that's 182. And then 7, divide both sides by 7. 7 goes into that 26 times, I think. So that means that the angle x is 26 degrees. Angle y is 5 times that. So 5 times 26. And that would be 130. And then angle z is 2 degrees less than x. So if x is 26, z's got to be 24. So if you add all those up, hopefully it'll come out to 180. So those are just some quick examples of problem solving where you would have a linear equation that you wind up having to solve. A couple other concepts to look at is the idea of zeros. A zero is of any kind of an equation or of a function is the value of x when y is 0. If you want to look at it graphically, a 0 is any spot that the graph might cross this x-axis here. So if I have a linear function like that, this would be my 0. If I had a quadratic equation like that, this point here and this point here would be my zeros. If I have a logarithmic kind of graph that looks like that, that guy right there, wherever it crosses the x-axis, that's my 0. Also, the point there, whatever this point is, if I do a coordinate system here, the x could be anything, not sure what it is, might be 2 or 1 or whatever, but the y value is 0 because it's not going up or down from this axis here, it's 0. So the 0 of any function is the value of x when y is equal to 0. And again, like I said, you could call that an x-intercept. So let's try a couple questions where they ask that. So they say to determine the 0 of any function, you plug a 0 in wherever you see a y or where you ever see a whole f of x thing. So example, in this case here, if I wanted to know the 0 of this equation, I put a 0 in right for the y. So I go 0 is equal to 3x plus 5. If it was in functional notation like that, I'd replace that whole f of x with a 0. And notice that each of these, it's the same equation, so to solve them, you'll do the same thing. Maybe take the 5 over the other side, make it negative, and then divide both sides by 3. So the 0 of this equation, or the 0 of that function, is equal to negative 5/3. Or graphically up here, negative 5/3 is be on the negative side. Here's 1, here's 2. Negative 5/3 might be over in there somewhere. So this equation might look, something like that. It's a linear function, so it'll cross the x-axis at negative 5/3. Maybe just why don't you take just a second, try this one. Pause, see if you can find the 0 of this function. And then press play. Okay, hopefully you've pressed play. So this would be 0 is equal to 5x minus 4. Add 4 to both sides. Divide both sides by 5. And you get x equals 4/5. That's the 0 of this function. Again, if I'm looking at where that is on the graph, 4/5 would be over in here somewhere. So this graph's got to look something like that. Okay. The one thing that some students get mixed up is the idea of a 0 versus a f of 0. And these two things are different. So in one case, a 0 is the value of x when y is 0. And f of 0 says what's the value of y when x is 0. See how that's different? So this one, to find a 0, what they're doing is they want to know what the x value is when y is 0. Whereas in this one, they want to know what the y value is when x is 0. See how they're opposite? So in order to figure out f of 0, or to figure out, in this particular case, what we're looking for is a y-intercept, what you do is you plug in, wherever you see an x, a 0. For example, here I have f of x equals minus 3x minus 12. So I'm going to put a 0 in everywhere I see an x. Notice that this thing here, that 0 isn't a calculated kind of thing. This is just a statement that says, what is the value of the function called f when 0 is placed in for x? So you can't do any calculation on that thing. It's just a statement, this part. But over here you can do some calculations. Minus 3 times 0 is 0, and 0 take away 12 is negative 12. So in this case here, the value of the function when x is 0 is negative 12. Notice that this equation would be the same as this. Y equals minus 3x minus 12. What I'm looking for is what is the value of y when you plug a 0 in for x. And notice in this case you get the same thing. Okay, so make sure you recognize that distinction between a 0 versus f of 0. They're two different things. Okay, last thing I wanted to do in this section was to look at some examples of linear functions. A lot of examples are written in formulas. And so sometimes we want to take a formula and manipulate it for a particular variable. And what we do is we just use those regular rules that we use for all linear equations to solve any formula for a particular variable. So in this case here, interest equals principal times rate times time. If they want to solve for time, they want to get rid of the p and the r. Since these are being multiplied, then to get rid of them, I would simply divide. So I divide here, the p and the r go away. I'm left with t. But if I divide this side by p and r, I have to divide this side by p and r. And so this equation solved for t would be I divided by p times r is equal to t. Okay, here's another one. P is equal to 2L plus 2W. Says solve for L. Okay, I want to solve for L. So this is what I want to get all by itself. So I have to get rid of this 2, and I have to get rid of the 2W. First, I'm going to get rid of the 2W. So I'll subtract 2W on this side. If I do it there, I have to do it on this side. So I'm going to have P minus 2W is equal to 2L, because these cancel. Now I just want L, I don't want 2L, so I'm going to divide everything by 2. So this one here would be P minus 2W over 2 is equal to L. So there I used, I guess, the addition property or subtraction property first, and then the division property to get L by itself. Here's one interesting last question we'll do in this section, where they say they want to solve this equation for x. But the only problem with that is that x, there's 2 of them. So if I've got 2 x's and I want to solve for x, I need to somehow get 1. Now, sorry, there is a nice little trick to get 1x by itself. If you have 2 terms like this right together that each have the same variable, what you can do is factor out that variable. So if I factor 3 or an x out of here, I'm left with 3y. If I factor an x out of here, I'm left with 1 is equal to 8. Now I only have x, just 1x. I want it on a side by itself though, like here's my equal sign, like I have to get rid of this. So it's x times that. So to get rid of that, I'm going to divide both sides. So I'll divide this side by 3y plus 1. That'll cancel it out. But if I do it on this side, I have to also divide it on this side. Okay, so x would be equal to 8 divided by 3y plus 1. Okay, so those are just some quick examples of looking at linear functions and linear equations and solving. I'd encourage you to try some questions in the book and practice those.